So very good morning students. And in the last class we have seen the OSI layer architectures. Okay, so we have seen the different layers, and then after that we have seen the TCP/IP protocols also. So in the TCP/IP we are having five different layers, and in the TCP/IP we are not having that presentation session layer as OSI layer model having. Okay, right. So after that we have to understand some protocols. Okay, so first we need to understand what is the protocol, and in this class we are going to see about the TCP IP and then UDP only. Okay, so let me move on to the class, then you can understand something. Right. So the first thing is IP. So it is the internet protocol, right? So first we have to understand what is protocol. So protocol is a set of rules which is used to transfer the data in the right format. Okay, because we are using the firewall or some other antivirus or some other third-party softwares to regulate our internet communications. Okay, so what they are doing, so they are doing this only, they are applying some rules, and then based on that rule only our data are getting transferred to that source or destination machines. So here we are going to see about the internet protocol. So simply, if you are using the internet, then how the data are getting delivered from source to destination, that's what we are going to see. And you see here we are mentioning the diagram, internet protocol structure. Okay, and you see here they are telling there are two versions in this internet protocol, version 4 and then version 6. Okay, and version 4 we are using, it is a classical one, because it is a 32-bit address value, and then right now we are lagging with some address spaces, so that's why they are increasing that volume version from version 4 to version 6, because version 4 contains only the 32-bit information, but version 6 contains 128-bit information. So we are having the lots of the trillions of billions of IP addresses we can access in this IP version 6, not in the IP version 4. Right. Let me see into this structure. You see here, this internet protocol totally contains the 20 octet bits, right? And they are classifying these bits into 32 bit length. Here we are having that version, and IP header length, and then types of services, and then the congestions network model, and then total length, identifications, flags, fragment offset, header checksum, and then protocol, time to live, source address, destination address, and then options plus padding. So these are the fields which are working along with that uh, our delivery functions. Okay, so these are the flags only used in this IP, that means the internet protocol. So let me see one by one. First it is a version. Okay, so first we want to understand which IP versions they are using for transferring the data. Suppose if you are transferring some data from your machines, then automatically it will take that IP version 4 only, not in the IP version 6. Okay, even if you are applying the command IP config in the system, then automatically it tells that IP version 4 addresses, not the 6 addresses. In the rare case, in some system it will show the IP version 6 addresses. Okay, right. So whether it is a version 4 or version 6, that it will be displayed in this version field. After that, IP header length. So what is the length of this IP header? That size will be specified in this 4-bit information. Okay. After that, the services. What kind of services? Because it is a distributed services only. So what kind of services that IP want to do now? That will be specified in this particular field. And then congestion. So here it will check whether in this network whether there is a congestion or not. Okay, because if any traffic will be there, then automatically it will take some remedial actions which is available. Otherwise it won't do anything. Simply it discard a packet. That's it. And then the total length. So the total length means for what is the total length of the data packet, and then this IP header. So that it will be mentioned here. And then identification, so it is a packet identifier, that means the protocol identifier here. And then time to live concept, so that means already we have discussed something about the session, right? So this is related to that only, because how much time this packet want to be in the queue on that internet. Okay, if any time durations expired, then automatically this protocol will drop the packet. okay, or what is the rule set for that time to live concept. Based on that, it will apply that rule and then it will do some functions. Okay, that's what they are mentioning, the time to live. So they will mention that time period over here. Okay, and then protocol. So based on this data and then services, they are giving the protocol here. So that protocol will decide what kind of operation it has to perform. That's it. Then header checksum. So that checksum we will see in the later, the error detection concepts. Okay, because it will verify the data reliability. That's why we are going for the checksums. And then source address, destination address, it is important because once the data is delivered, then the data must contain the source and destination address, because the receiver place, the receiver wants to understand who is the originator. Or if you are receiving some data from that some opposite party, then you must understand who is that sender. Okay, so in the same way we have to, the destination also we need to mention, because you are sending some data. So to whom you want to send the data, that you have to mention here. That's what we are mentioning, that source and then destination address. Like if you are posting some letters in that envelope, then in the envelope we are mentioning that from and to address. Like the same way here we are mentioning the source and destination addresses. Okay, so based on that, that IP will understand where to through the packet. Okay, right. Then next one is options plus padding. So the padding is always used to add some excess zero with that informations, because what will happen sometimes, if you want to pass that 160 bits information, then I'm not having that much information. I'm having only the 142 bit information. So the rest, 18 bits. So I cannot send that 18 bits as a free. Okay, so I need to fill that 160 because I want to make it a pixel length. That's why I'm just adding that padding bit value here. Okay, so these are the things we are going to sorry, these are the fields are available in this internet protocol. And then they are mentioning that IPv6. So as I told you before, it is the enhancements over the IPv4, because the IPv4 just contains the 32-bit information. So with the help of the 32-bit, we can make only that uh, 1 million or something. In this range only we can make the IP addresses. Okay, and we cannot use all this 1 million also, because if you want to assign IP address for your system, then you have to follow some rules. Like it has 5 different classes, like class A, class B, class C, class D, class E, like that. And from that you have to use only that first three classes, not on the D and E, because class A, class B, class C only the user classes. So there you have to use, and in those classes also you cannot use all the IP addresses. Okay, because we are having some private IP ranges in this three classes. So within that private IP ranges only you can pick IP address and you can assign. The next other IP address will be assigned with some website, internet address assigned authority. Okay, they will do this. We cannot use that IP addresses. Okay, so now we are millions of people are living here, and then some other world also there also we can see lots of people are living. Okay, so if we are going with IPv4, then we all cannot use this different IP addresses. That's why to give that a large spaces, they are enhancing this IPv4 into the v6. There they are using the 128 bit interface. Okay, so if you're using the 128 bit, then the trillions of IP addresses easily we can make. Okay, so that part, even if you see, right now all the people are using their mobile phones, and they are using the internet in the mobile phone also. Okay, so simply we got to use the IPv4 address in this mobile phone, so automatically that IPv6 address will be applicable in this mobile phones, and they are using here. Okay, and they are saying it is not backward compatible. So if you are using the IPv6, we can go with the backward compatible with the IPv4. Okay, that's what they are telling. So the next one is the transmission control protocol. So I told you in that last classes itself what is the TCP, right? The TCP is not holding the IP address of any data. It holds only the port addresses information, because it is the service level protocol. So if I am passing some data, then the TCP will confirm that okay what kind of data it is and which port will access this data. Okay, so based on that only it will pick that particular port and then it will give the destination. Okay, that what in the TCP PDU title they are given called TCP segment. Okay, in the second point they mentioned include source and destination port, not the IP addresses. Okay, so the port is something different. Port is it is starting from 0 to 6535 sorry 535. So that means 65,000 535 port numbers we are having, port services we are having. Okay, so because that much services available in our system, so based on that it will pick one port number and then it will attach with the data and then it will send to that particular port. That's it. So this kind of operation will be done with that TCP. The next one is TCP header. Okay, we know that. Okay, it is looking for only that port. Okay, and it will find out from which port it is coming. Okay, because if I'm delivering some data, then from which services deliver that data, that it need to understand. Okay, that what in the TCP header we can see that it contains the source port and then destination port. Suppose I'm sharing one music files, then with the help of MS documents or notepad I cannot create this music document, I cannot share that. Okay, so the particular supported applications only can share that data. That's why they're telling from which port it is coming. Okay, so it contains the source port and then destination port. After that, as I told you, each and every packet will be divided into some groups. Okay, we are not sending the packet as a whole, right? So for each and every divided packet we are attaching some sequence number to identify whether all the packets are received as from the source side or not. Okay, so based on this sequence number only the TCP will understand okay all the packets are received. If any sequence one sequence number is missing from the packets, then it will send it will send the negative acknowledgement to that source address like okay I missed this packet, please resend it again, like that it will give some acknowledgement. So based on that acknowledgement number the source machine will resend the packet again. That what they are telling, sequence number and then acknowledgement number for filled here. The sequence number is meant for all the packets and then acknowledgement for the received packets. Okay, after that they are using the header length and then unused flag. Here that unused is always zero because these fields are not used in some other functions. Okay, that's why they are giving the zero. Okay, and checksums already told you, so it is used for error corrections space. Okay, and then urgent pointer suppose I'm passing some data and then I just wanted to deliver that packet the fast mode. So what it will do, it will assign this urgent pointer with that data. So whatever the queue of data is there in that line, simply this urgent pointer will make that particular data move on fast. Okay, that's why we are using this urgent pointer here. And then padding, as I told you before, the padding is just adding the extra bit informations for making it pixel length. That's it. Okay, and the TCP header length is whole over it is 0 to 31. That means the 32 bit informations. Okay, all right, and then next one is the UDP. So if you're looking for the services, then TCP and then UDP will do these kind of services, and then both are doing the same operations. The difference is TCP is the connection oriented and then UDP is the connectionless services. Okay, so that if it is a connection oriented, in the TCP we can get the reliability, but in the UDP we cannot get the reliability. That means we cannot lay on this UDP packet. Okay, if any packets are transferred by using this UDP, then we cannot assure that whether that packet is 100% delivered to that destination or not. Okay, but if you're using that TCP, then with the help of that acknowledgement number, we can say that okay, all the packets are getting delivered. But in the UDP, we are not using that acknowledgement number. So if any packet is lost or is dropped or whatever something happened to that packet, means that UDP won't take the responsibility of the lost packet. Simply it will deliver the packet. That's it. Okay, that's why we are telling the UDP is not reliable one. Okay, so you see here they are telling that it is not guaranteed delivery, and then no preservation of sequence, and then no protection against the duplication. So we cannot rely on this UDP here. The next one is PDUs in TCP/IP. That means the packet data units in the TCP/IP. So that means what you know the packet data units I said. So packet data unit is a packet only, but based on the layer it moves, it added some extra information along with it. Because you see, I told you that packets are transferred from the physical layer. So while moving on the physical layer, it will attach the MAC information. Okay. After that, in the data link layer, it will attach that LLC information. In that network layer, it will add that IP information, and then TCP transport layer, it will add that TCP/IP or UDP information. So, right. So like that, along with that user data, it will add some extra header information. That's what they are mentioning here. You see from the top to bottom, in the application byte stream, only it contains the user data, because it is the first layer from the top. So I told you already, right? It is a user interface place, so user can see only that application information. So it is a simple data. After that, the data is moved onto the transport layer. So when it is moved onto the transport layer, there that TCP header will come into the picture, because the transport layer only the TCP will work, right? So here it will find out what is the source and destination port number. So how can it will understand? So with the help of the TCP header, that's what in the TCP segment it will add the TCP header. After that, it will move the packet into the IP data, that is the network level. Okay, so here it will attach the IP addresses of the source and destination machine. Okay, now what will happen? We got the port number of the source and destination number, and now we got the addresses of the source and destination address, sorry, missions. Okay, so what is happening here? Now that network layer will route the packet to the particular IP addresses. Okay, so that network layer and the network header will take care of these things. Okay, so after routing that packet, then it will try to read the destination address, and then based on that, it will transfer the packet through that internet. That's it. And this topic is over. So today's topic is everything is over. Let us see next class. Some of the topics we will see in the next class. Okay, because we have covered only that TCP/IP protocols and something. We have to see that error correction detection method also, that we will see in the next classes. And if you have any doubts in this class, that you can clarify with this kind of my email ID, and then my mobile number is there. You can clarify with that. And thank you. We'll see you in the next classes. Thank you.